Hey guys, today we're starting unit 15. I uploaded the unit packet a couple days ago. So if you did not print it out, you should do that first. If you're not printing it out, just do your best to take notes as we go. So I'm going to screen share. We're only going to do pages 1 and 2 today. You all right?
Yeah! I'm never gonna be better.
Ay, ay, ay. Never better. Okay. All right, so this unit is on acids and bases. It's a pretty easy unit, I think. So that'll be good for this one. The next two are kind of weird after this, but we'll get there when we get there. Okay, so operational definition of acids and bases just means what are their properties. So acids are electrolytes. That means they conduct electricity when they're in solution. They dissociate into ions. So remember, more moving ions you have, the more conductive they are. Acids taste sour, like a lemon. The pH is less than 7. Mason, are you okay? When you add an indicator named phenolphthalein, this is a ridiculously long word, remains colorless or clear. Number 5, if you have blue litmus paper, it turns red. So it's a piece of blue paper and you put it in and it turns red. Reacts with a metal. And when it reacts with a metal, it makes hydrogen gas. Oops, I spelled that wrong. There. And then an acid neutralizes a base. Meaning it'll produce something neutral like water. Okay, so bases are also electrolytes. They taste bitter. The pH is greater than 7. Let's go back to bitter. Something that tastes bitter, I mean, you don't generally taste soap, but you may have gotten soap in your mouth, but like baking chocolate, I would say is pretty bitter, or dark chocolate, something like that. All right, so phenolphthalein, I'm just going to use the abbreviation, which is PHTH, turns pink if it's with a base, like a fuchsia pink. This time, if you have red litmus paper, it turns blue. Bases are also slippery and caustic. And caustic means it can burn you. So there's a misconception that acids are bad and bases are good. If you have a strong base, that can also be really bad for you. All right, and then bases neutralize an acid. Okay, so those are the basic properties.
Mommy,
What's up, buddy?
I need help pulling my pants.
Really? See ya. Good luck. Okay. Now there's two conceptual definitions. The first is called the Arrhenius theory. That means that acids usually increase the hydrogen concentration. So they usually contain an H+, which you could also say is H3O+. in solutions. So for example, HCl, when it's in water, it'll make H plus ions and Cl minus ions. Bases increase the hydroxide concentration. So bases generally have an OH minus, for example, NaOH. So bases end in OH unless it's a carbon with an OH, and then it's an organic alcohol. Okay, the next one is called the Bronsted-Lowry theory or the alternative theory. Acids are proton donors, which is just another way of saying hydrogen, and bases are proton acceptors. Sorry, it was a little crazy a minute ago. H plus. And this is the one that the Regents prefers to test on. Okay, so moving on. Okay. H plus ions are called protons, or you could say hydrogen. H3O plus ions are called hydronium. And these two are used interchangeably to mean that you have acids. OH minus ions, remember, are called hydroxide. You can look up H3O plus and OH minus back on table E, which is your polyatomic ion table. Okay, so this is kind of the chunk of what I want you to know today. The BAD rule. BAD rule stands for bases accept, acids donate. So we're talking about bases accepting H plus and acids donating H plus. So this is how I do the problems. Draw a line through the arrow. And I pick one, like let's look at the first one. So HF. And then I see, what did HF turn into on the other side? So it turned into F. So does that mean that HF got another H or it gave away an H? So if HF turns into F, that means it gave away an H. So I would draw an arrow showing that this H goes to H2O. So that means since bases accept, acids donate, this is your acid and this is your base. Now I'm going to look at the reverse reaction. So F needs to turn back into HF. So F does not have an H to give, so it has to get an H from H3O plus, acid, base. Okay, let's do the next one. All right, so I'm gonna look at, just pick any of them. I'm gonna pick NH3 because it came first. So NH3 needs to turn into NH4. So did NH3 get an H or lose an H? Well, it changes to NH4, so it gained an H from the H2O. Bases accept, acids donate hydrogens. Now going in the reverse reaction, NH4 needs to change back to NH3. So NH4 needs to donate an H. So acid, base. And then the last little bit on this page says water can be amphoteric. So if you look at water here and you look at water here, water can act as an acid or a base. So it can donate hydrogen or it can accept hydrogen. So that is what amphoteric means. Okay, so on the next page, there's a bunch of practice problems. I'd like you to push pause and try the practice problems. And then when you're done, come back and I'll go over them. So we're doing the whole page. So even those multiple choice questions at the bottom. Okay, so quickly, these are the answers. HF needs to change to F. So donate. F needs to get back to HF. So this is acid, base, acid, base. H2PO4 needs to change to H3PO4. So it needs to get an H. It gets an H from water, base, acid. And then H3PO4 needs to lose an H to get back to H2PO4. So basically, if the one you're looking at gains one on the left side, it has to lose the H on the other side. So this is the acid, base. Hey, Maddox, can you be quiet a little bit? Because I'm recording something. H2SO4 changes to HSO4, so it loses an H. Donate, accept. This one needs to get another H to get to the other side, so this one accepts. H2O donates. Oh my gosh, that laugh he does is so... Okay, C2H3O2 changes to C2H3O2, so it gets rid of this H. Acid, base. And then this one, it lost the H in front, so it needs it back. Base. Oh no, sorry. Acid, base. Okay, and then the next side, base, acid, base, acid. This one donates to turn into SO4, acid, base. Accepts, base, acid. So just, I would always write down like bases accept, acids donate, to just remind yourself what they do. On the next one, NH3 needs to turn to NH4, so it gets an H. Base, acid. NH4 needs to get back to NH3, acid, base. And then the last one, HSO4 needs to lose the H to get to SO4. Acid, base. And then SO4 needs to get an H. Acid, base. Okay. And then okay, so now going through the multiple choice, these go back to stuff from page 1. If red litmus paper turns blue, that means it's a base. If blue litmus paper stays blue, it means it's either a base or it's a neutral, so I'm not going to use that. Phenolphthalein turning pink is a base. According to the Arrhenius theory, a substance that yields hydrogen ions is an acid. Okay. And then number 3, conducts electricity means you have an acid or a base. Blue litmus paper turning red means you have an acid. Okay, and this one, this is like the arrow thing we were doing. Bronsted bases accept. Okay, so H2S needs to change to HS. So this is acid, this is the base. And then on the other side, NH4 needs to change back to NH3, acid, base. So I'm looking for this and this one in my answer. So I have choice B. Okay, and that's it for today. I got these glasses. They're blue light glasses because I've been getting headaches at night. Anyhow, so that's all you're doing today. Tomorrow you'll have a homework assignment. But that's that. Okay, see you later.